Have you ever really stopped to think about the device you're watching this on right now? I mean, how did we go from a machine the size of a room to something that fits right in the palm of your hand? Well, today, we're going to take a journey into how computers evolved, from what was basically a giant calculator to the powerful, thinking machines we use every single day.
It's a pretty wild leap, isn't it? From these massive, clunky machines filling up entire rooms to the sleek, smart devices we pretty much can't live without. So how in the world did this incredible transformation happen? Let's find out.
All right, here's our game plan. First, we'll break down how computers actually think. Then, we'll jump through 5 massive leaps in technology. After that, we're going to peek inside your device, explore the incredible World Wide Web, and finish up with the dawn of AI and, what it all means for us.
Okay, so to really get how computers became so ridiculously powerful, we have to start with the basics. What do they actually do? Because no matter how fancy or complex they get, every single computer, from the very first ones to the one in your phone, is built on 4 fundamental ideas.
And here they are. It's actually a really simple 4-step dance. First, you give it input, like typing on your keyboard. Then the computer will process that information, let's say it's adding 2 numbers together. Next, it gives you an output, showing you the answer on the screen. And finally, it offers storage, so you can save that result for later. Input, process, output, storage. That's it. That's the blueprint for literally everything a computer does.
So, now that we've got the blueprint down, let's talk about the hardware itself. The whole story of computing is usually broken down into 5 distinct generations. Each one was defined by a totally revolutionary leap that made computers smaller, way faster, and a whole lot smarter.
Just look at this timeline for a second. The pace of change is just incredible. We started with these huge, unreliable vacuum tubes. Then, boom, the transistor was invented, and suddenly computers got smaller and way more reliable. Then came integrated circuits, which packed even more power into a tiny little chip, and that led directly to the microprocessor, the engine that started the whole personal computer revolution. And today? Well, today we're stepping into the 5th generation, the age of AI.
This comparison really says it all, doesn't it? The first computers were absolute giants. They were ridiculously expensive, they guzzled power, and they were super unreliable. The microprocessor changed everything. It gave us these compact, affordable, and dependable machines. This wasn't just a small upgrade. This was the massive leap that brought computing power to the rest of us and put a PC on your desk.
Okay, we've seen the history. Now let's pop the hood on a modern device. Everything that makes your computer or your phone work can be split into 2 essential categories: the physical parts you can actually touch and the invisible instructions that tell all those parts what to do.
So first up, you've got hardware. This is all the physical stuff. Your screen, your keyboard, the chips humming away inside. If you can pick it up or tap on it, it's hardware. And you'll see that these components map directly back to those 4 core functions we talked about: input, processing, storage, and output.
Now, right at the heart of all that hardware is the Central Processing Unit, or CPU. You can literally think of it as the brain of the computer. It handles all the thinking, all the processing, and carries out every single command. Its speed is measured in hertz, and get this, 1 hertz is 1 instruction per second. A modern gigahertz CPU, that thing can handle billions of instructions every single second. That's the speed of thought for your machine.
So if the hardware is the body, then software is the intelligence. It's the set of instructions that tells the physical parts how to act. This includes the big boss, the operating system, like Windows or iOS, and all the apps you use every day, from your web browser to your favorite game.
Now this is a super important concept: memory. Think of RAM as your desk. It holds everything you're currently working on, and it's super fast to access. But, and here's the catch, when the power goes off, poof, the desk gets cleared. Your hard drive, on the other hand, is like your filing cabinet. That's your long-term storage where you keep everything safely tucked away, even when the computer is off.
So far, we've pretty much just been talking about a single computer. But the real revolution, the thing that changed the world, happened when we started connecting all of them together.
So what exactly is the Internet? Well, at its core, it's a giant worldwide system of interconnected computer networks. It isn't one single thing, but a massive network of networks that allows millions and millions of devices to talk to each other across the globe. And the way we navigate this enormous network has become so simple, it's basically second nature. You open a browser, you type what you're looking for into a search engine, and you click a link. That's it. In those 3 little steps,
You've just accessed information from potentially halfway across the planet. It's kind of amazing when you think about it.
All of this incredible connection paved the way for the next great leap, that 5th generation we mentioned. We're moving beyond computers that just follow instructions to computers that can actually think and learn on their own. So welcome to the age of artificial intelligence.
This quote really captures the massive ambition of this new era. It's not just about making computers faster or smaller anymore. The goal now is to create machines that can learn, adapt, and solve incredibly complex problems without needing a human to program every single step. So what is AI really? At its heart, it's the simulation of human intelligence. It's about programming machines to think, to reason, and to learn from experience, a lot like we do. From playing complex games to understanding what we say, AI is already all around us.
All of this unbelievable technology, from the CPU in your phone to the AI that recommends you a movie, is now deeply woven into our daily lives. It's completely changed how we work, play, and connect. But as these devices become extensions of ourselves, it's probably a good idea to think for a second about how we physically interact with them.
And that brings us to something practical: ergonomics. I mean, as we spend more and more time with our devices, the way we sit and use them really matters. It's simple stuff, right? Keeping your head upright, your wrists straight, making sure your eyes are level with the top of the screen. These little things can prevent a lot of strain and injury. It's really about using this amazing technology in a way that's healthy for our bodies too.
So we've gone from room-sized calculators to pocket-sized learners. It has been an absolutely incredible story of shrinking hardware and expanding intelligence. And that leaves us with one final, very exciting question. If this generation is about learning, what will the next generation be capable of? What comes next?